Okay, there we're recording. Excuse me. Here we go. Is this a good font size for everybody? Can you just put a thumbs up if you're good, or put a plus if you want me to increase the size a pip or two. Cool. I'm going to assume that this is good. All right. So last time we didn't quite get through everything here. Excuse me, I had this pulled up and then I reset this. We covered assignment, we covered incrementation. We just kind of touched on this. Quick note on this incrementation bit. This is going to come up later. This is kind of an important concept that we'll be coming back to. It'll be fairly central. And we talked about scalar types. Integers and floats are what we think of, what we're familiar with thinking of as numbers. Floating points are what you think of as decimal place numbers. They have a fractional value expressed with a decimal point. They can have, the same value as a whole number. That's just expressed as 0.0, but that's still considered a float. And then integers are just whole numbers. Either one can be positive or negative, and you just put a negative sign in front of it, just like you'd think you would. Booleans are considered a numeric type, but they only have two possible states, true and false. They're a simple type, but they're very central, and we use these for performing logical operations. I showed some operators, the equality operator, inequality operator, greater than, less than, greater than or equal, less than or equal. These all, sometimes these are called comparison operators. So we can compare A to, okay, switch files there. A to B in some way. And so A equals 10 and B equals 10. Something like that. And we'll get the following. So they're equal is true, A is equal to B is true, A not equal to B. So you get the picture. These expressions yield a true or false value. So this is kind of a concept if you're new to programming, right? An operation has inputs. These are the inputs here, A and B, and it has an output, which is, in this case, true or false, right? So the input is, or the output is sometimes the same type as the input, and sometimes it's not, right? So we think about this as an operation, just like we would think about, A times B as an operation, right? These are equally as much operations, they're just different kinds of operations. Cool, so that's Booleans. Strings are collections of characters. Some kind of nifty things we can do with strings. So let's have a little recap on strings. And I think I'll start my overview for today. We have evaluation, execution, evaluation, execution, types, abstractions, conditions, or well, let's call these control flow. Iteration. We'll be getting into control flow a little bit today. We'll be getting into iteration fairly soon. So data types, int, float, these are what we think of as numbers, bool, also technically a number type, string, or str is the formal type identifier. I'll stick with those. Yeah, so strings just hold collections of characters. The way we can create a string is with quote characters. So if I want to, let's say I'll make a variable equal to a string, we'll call it name, equals, I'll just do my name, Clark, and we can print hello. Name, something like this. Right, so we can use quotes to delimit the strings. And we can use double tick quotes or single tick quotes. I touched on this earlier. It's the Pythonic thing to do is to use single tick quotes. That's what most people do. I believe that's what Tovio prefers to do. I prefer to use double tick quotes. Like I said, it's really just an aesthetic choice. I didn't get into the PEP 8 documentation. I actually meant to repost a link for that. Let's see if I have this up here. I'll get that maybe over the break and post a link to the PEP 8 documentation. PEP 8 is the official style guide for Python. And that gets into like beautifying your code and making it aesthetically nice, the code itself, so that it's maintainable and nice to deal with, which is a fairly important thing. So you don't have to do it. You don't have to necessarily do everything that PEP 8 specifies, but it'll help you think of things to standardize. The important thing is that, more or less you do things the same way every time, and just pick the way you like. You can experiment around, pick the way you like, do it that way every time. And if you deviate from that, be clear about why. At least have there be a justifiable reason why you deviated from it. And if there's not, then maybe take a little note or leave a little comment in. But yeah, so that's the thing. But just so nobody, I'm saying this part so you don't get confused if you see strings that are delimited with single tick quotes and strings that are delimited with double tick quotes. Python doesn't see them as different types. Like there's not something that one does that the other doesn't do. So cool. Why is bool of happy true? Because maybe Python is a happy language. This is a cool question. I see somebody's been experimenting with casting various things to booleans, as I suggested. That's cool. Bool, boo. Let's do bool. Print. So let's look at this. This is a cool question, actually. So last class I mentioned that you can cast any type to a Boolean. The types we've looked at are int, float, and bool. So every built-in type in Python has what we call truthy and falsy states or state. So with numbers, an integer 3 is truthy, an integer 0 is falsy, an integer negative anything is truthy. True, false, true, right? So it's kind of weird that negative numbers are truthy, but they are. So with numbers, and this goes for floats, I think I demonstrated this with floats as well. If I have negative 0.000, just so long as I don't cause an underflow that Python just ends up reading as 0 anyways. You know, if I have a very small value that does, as long as it doesn't underflow to 0, it's still truthy. So it doesn't matter. There is no higher logic to that. If the value is 0 with a numeric type, it's falsy. If it's not 0, then it's truthy. Doesn't matter if it's positive or negative, doesn't matter if it's fractional, doesn't matter if it's close to 0. It's going to be truthy if it's not 0. Okay, so that's for numbers, and I know that doesn't answer the question that was asked particularly. But I figure it's just worth covering kind of the whole concept. So with strings, this is kind of funny. If I have my string equals an empty string, this is valid. This is a string that can, this is a string. This is definitely, absolutely a string. It just doesn't contain any characters. And you might think, okay, well, it's a string. It's just, who cares? Empty string, it's important to know that empty string is a valid string. And we can, let's play around with this for a second. My string. So I just ran this, nothing happened. It did print out my string, but since there's nothing in it, we didn't see anything. It didn't print anything out. So if I put this in, I'll actually put this in a list, we can see we get the list shows us that we have the quote marks, but there's just nothing in the quote marks. We'll get into lists later. Don't worry, that I pulled that out of nowhere, I know. But so if I cast this to a bool, this empty string bool, that's going to be false. So this has a similar thing, right? So if you have, and this goes for any collection type. So strings are our first collection type. It's a collection of elements. Strings are collections of only character elements, but there are other collection types. We'll get into tuples and lists and dictionaries and sets as we progress. But right now we're just looking at strings. So for strings and all of the other collection types, if they're empty, they're falsy. If they're happy, they're truthy. No, if they have any contents, they are truthy. So it doesn't matter what it is, it's truthy. If it's a space, it's truthy. If it's an underscore, it's truthy. If it's the string false, it's truthy, right? Even though this is, if this weren't a string, this would be the Boolean false. It's a string with characters in it, therefore it's truthy. So it doesn't matter what the characters are, whether it's happy or sad, it's always truthy. So cool. I know that was kind of a long answer, but I didn't really dive into truthiness and falsiness, I don't think, too much, but it's a good opportunity to cover that. Let me know if that was helpful. Just give me a thumbs up, or if you have any follow-up questions, that's cool too. Okay. Cool, so that covers a little bit of strings and Booleans. Cool, awesome. Hope this wasn't out of nowhere. This, I'm creating a variable, setting it equal to some string, and then I'm using another string, and this could be like greeting equals name, or equals hello, and then I could do greeting plus name is going to be whatever that is, hello world, something like that. So I can do whatever I wanted there. These can be two variables like this, or they can be both the string literals like that, whatever, any combination therein. When we use the plus sign to combine two strings, this is called concatenation. And it actually, what it does is it evaluates cat is short for concatenation. Concatenated string, it evaluates to the concatenated string, the full string. So this evaluates to another string that says hello and Clark. So I could print cat string and it says hello Clark. And then of course I could change either of these, world, hey, whatever I want to do there. So we can use the plus operator to combine strings together, and that combines them into another string. We also, we'll get back to this, but we could also do something like my string equals empty string. And then we could say my string plus equals, remember this plus equals for numbers. This also works for strings as well. Plus equals H E L L O. And then we could print my string. Hello. So we can accumulate things into the string that way. We can add things, and we'll be talking about accumulation later. Well, not in this lesson, but in a lesson shortly. Okay, so that's strings. None. So I just touched on this. None's pretty simple. It's Boolean has two states, so it's what we think of as a binary type. None is, you could think about a none as a unary type. It has one state, which is none. Surprise, surprise. So some var, some variable equals none. Print some var. Okay, cool. So this can be useful if you there are times when you might need the variable to exist, so you don't get like you don't get an error that says if you try to use it, it doesn't exist. But you can't determine an initial state. It's either difficult or impossible to correctly determine a starting state. You can just start it at none and then find a way to give it an initial state once your problem logic is your solution logic is underway. It's also useful, like maybe some var under certain circumstances in my program, I'm writing a program and at some point I want it to be some string. Or at some other point, or maybe under some different conditions, I want it to be some number. I can set it at none, and none is like saying, maybe we don't know what the type of this is going to be yet. So we'll just start it at none, and we'll let it evolve into whatever type we need it to be as we need it to be that. So those circumstances aren't super common, but those are some uses for none. Really, the reason to know that none exists is that, so I've been showing you some functions. Print is a function that we've looked at. Type is a function. We've also looked at int, float, bool. Come on, stir. I'm trying to think, I think these are all the functions that we've covered. So these are built-in functions, and we're going to get into how to build your own functions as well. So functions take inputs. They have a name. They take inputs. The inputs go inside the parentheses. Some functions don't take inputs, but most do. And most functions also give an output. For functions, so in Python, every function has to give an output, but if one isn't explicitly stated, none is the assumed output. So none is always the default output of a function. So Of these functions, there's only one that has no output or has an output of none. So a lot of times it's a little weird. We'll refer to a function as having no output or return. We'll use the word return instead of output, but we'll refer to it as having no return value, but we know that what that really means is that it returns none. So print actually has no return value, which might seem weird. You might think, well, it returns what's being printed, and that's not true. It prints what's being inputted. It prints its input. What that means is it makes the input visible on the terminal. That is, I mean, you could use that as an example for like a definition of the term output if you wanted. It's a kind of output, but it is distinctly a different kind of output than the kind we mean when we say a function returns or outputs a value being one of the types or one of the other types that we haven't talked about yet. One of the types we've talked about or one we haven't talked about. So when we say it outputs a value, we're talking about it outputs one of the data types in one of its various states. So there are lots of different kinds of outputs it can have, right? Type actually returns the type that it returns is a type. It's just kind of weird. We can prove this by asking what's the type of type. Let's see. Oh, what did I do here? Oh, I didn't. It's yelling at me about these. Okay. So you can see the type of type is type, which is kind of weird, right? Let's drill down a level, right? So the type of none is none type. Things like that, right? So let's see, what's the type of print? That's going to be none type as well. So this is silly. I know I'm getting the type of type and now I'm printing print, right? It's very meta today, but if I print, that's going to give me none because print returns none. And that's not because I didn't pass anything. I could say this is what I'm printing, right? So that's going to print out there and we will see it print. This is what I'm printing. And then that prints off none. So that's kind of an interesting one. But all of the rest of these return a value. Int returns an int, float returns a float, bool returns a bool, stir returns a string. So thus far, we've really only looked at the, casting style functions as well as print and type. So. Okay, cool. So that's none. Just to recap that real quick, the important takeaway there is that some functions don't return anything. If no return value is given, then the return is assumed to be none. This will come in useful when you're writing your own functions. And, invariably this will happen. You'll write out all the correct logic and, maybe submit it in to learn and forget to put in a return, forget to specify what you're intending to output. You may have done the algorithm correctly, but if you forget to specify what you're outputting, then the answer is none. The function evaluates to none, which will be confusing, especially if you don't know that can happen. Cool. All right, let's move on. Variables and logic. So variables are our first kind of abstraction. Variables. Okay, so this just says you can think about variable assignment as giving a name to something so that it can be accessed later by different parts of your program. you can use variable to store any data type. So this is useful for reusing values that you calculate. You can imagine, maybe I have how would I do this? How should I do this? Let's do something like n equals 4. Let's say we want to calculate the factorial of 4. We could say prod equals 1. We haven't got into loops yet, so just pay this no mind. Range 1 to n plus 1. Prod times equals I. So this will give me the factorial of n. Shoot. I thought this would be a better, no, this is not a good example. That's not a good example. I was trying to give an example of, like, let's say I don't want to write that code every single time, but let's do something like if I had some operation that I needed to perform where we have like 2 times n to the m or something. So maybe I don't want to write this out every time I need to use it. We'll have values for n equals 12 and m equals, let's say, 42. So we could say O equals, or just we'll say var equals this, right? So rather than having, if I need to use this in multiple places, I can just capture it in a variable. And then every time I need it, I can just say var, rather than writing out this kind of clunky bit of math every time. Cool. Okay, so declaring variables, I've given lots of examples at this point. But just to kind of look at the anatomy, because this looks really simple, but there is some anatomy that's worth knowing. I'm going to refer to the name portion as the identifier. This is not, even though I've been calling it equals, I am trying to, it's so ingrained, it's a bad habit. I should really call it gets. So this should read n gets 12, m gets 42. This is not an equals operator. This is assignment. We think about this, the formal name for this and the way we think about this is as the assignment operator. And it's directional. It assigns the thing on the right to the thing on the left. So it assigns the value 12 to the identifier n, right? And then this one, we have the assignment of the value 42, the integer value 42, to the identifier m. Here we have the assignment of whatever the result of 2 times n to the power m to the identifier called var. Oh, that's quite a large number. Look at that. All right, cool. Yeah. So we can also declare multiple variables on one line if you want. And there isn't really, there are times when this is kind of useful. There's an underlying concept here that's expressed in this, which is why we show it. And we're not going to talk about the concept now, but I want to introduce the idea. And then later when we introduce the concept, I'll be like, remember when we talked about multiple variables assignment, and we'll unpack this whole thing. So I could say x comma y, if I can hit the Y key on my keyboard, x comma y equals 30 comma 40. And if I print x and y, so x is the first identifier, and that's going to be assigned to the first value. Y is the second, so that's going to be assigned to the second value. If I had z, I mean, guess where that one's going to be assigned? To the third value there, right? So if I print off x and y, I'm going to get 30 and 40. Note though, if you have 3 identifiers, you better have 3 values. Otherwise, you'll say not enough values to unpack. Oops. So that'll be a value error. Conversely, or inversely or something, if I have 3 values, I better have as many identifiers. So this says too many values to unpack. Right, so in this case, we've got 3 identifiers and only 2 values. That's no good. So this says not enough values to unpack. This case, we've got only 2 identifiers and 3 values to unpack. This says too many identifiers, right? These are just flip sides of the same coin. You don't have to remember too many or not enough, which goes with whichever one. I have to see it every time, you know, but it doesn't really matter. I think of these as the same error essentially. So those are no good. So when you unpack a number of values, oops. There has to be an equally corresponding number of identifiers as well. Now, for now, you don't need to write your code like this. You don't need to use this when you're declaring variables. You can just stick to the simple, you know, 1 variable per line when you're making variables. That's just fine. Just for the sake of keeping things simple like this. Oops. Cool. So that's essentially the same thing, and you know, it's over more lines, but kind of simpler. So for now, that's just fine. But like I said, this ties into a concept that we'll kind of start talking about maybe next week. Okay. Giving it a good name. So yeah, so you should strive to give your variables well-defined, succinct names. There's a number of like kind of little what am I trying to think of? Abbreviations that I use for different variables. I will often try to include something about the type. Generally, if it's a number or a string, I might not like put num or string in it, but I might say n or m or num for a string for a single character from a, or excuse me, for a number. For a string, I might call it a word, meow, word, or my string, something like that. So you don't always have to do this in every circumstance, but if there's, what I would say is if you start to feel the slightest little bit of confusion about like keeping track of what things are and how things are changing, include just some part of your variable name. Let that include something about the type, right? So if it's a num, you might include num, my num, or what if that represents something, you could say like whatever it represents num, or if it's a string, you can do whatever this string. So something, often I'll include something about the type just to kind of keep myself aware of the types. And like I said, that is by no means a hard and fast rule, but it's a little tip that can be useful. So as you've seen me do, when I separate words, you might be familiar with other casings. There are different casing standards. And Python will allow you to do whatever case. So if I wanted to do, I believe, which one? Camel Case. Camel Case, which is, I don't know if I spelled camel correctly. Apologies. I am unironically dyslexic, so if I misspell things, that's what's going on. So Camel Case means that every time this is Camel Case, so every time I start a new word in my variable name, I just capitalize it, and that's what's going to delimit it. There's Pascal casing, which is the same thing, except I think the first letter is lowercase. I might have those backwards. I think I have those correct, but I don't like either of those. I prefer snake case. So this is snake case. So snake case, or sometimes just called underscore separation, right, is just separating the words in a variable with underscores. And I mean, it's, Python uses snake case. It's kind of easy to remember. I just find this to be, I find it to be readable. It is formally the Pythonic way to name your variables. And I highly suggest that you use snake casing to name your variables. If you try to use, like, sometimes this is called kebab casing with dashes. Some people like this. This Python does not support this. These are minuses, right? These are minus symbols. So it's looking for a variable called this minus is minus snake minus case. So that's not a valid casing. So if you're coming from like a language that supports that, then now you know. Okay. Okay. Yeah. So as you're working, it's important to just be thoughtful, give your variables good names that are descriptive to you. The thing about including some type information in the variable name is a tip that like I said, I've found useful. And that was one of those things like that I just kind of discovered after a long time of coding and kind of beating my head against the wall in the beginning, thinking like, oh gosh, I'm just having a hard time keeping track of what variable is of what type. And I just thought, oh, well, I could just, say LST if it's a list, or say D if it's a dictionary, or whatever. So yeah, that's just a little tip. You can take it or leave it. Boolean operations. So we've talked about these: greater than or equal, less than or equal, equals, or not equals. So we just kind of looked at something similar to that. Logical operations: not, and, or. So we have a number of keywords here. So if you've studied like formal logic, you might be familiar with like logic gates like AND gates and OR gates and NOT gates. And that's basically what these are. You can think about these like that. So we can make some truth tables. Print. So we'll do true and true is true. And then we'll do false. Like that. So any combination of false with an and is going to lead to a result of false. Let me get this nice and squared out. Uniformity. Okay, so true, false, false, false. Cool. Let's do this for or. Let's see what or is going to give us. Or, just so we don't get a big jumble, I'll comment those out. So true, 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 false. So if there's any combination of true, if there's one or two trues in the or system, then the entire or will be true. So true, true is true, false, true, true, false are all true, and then false or false is false. Not, oops. So if we do not, oops, not, come on, not true is going to be false, and not false is going to be true. We can also combine these. So if you've ever heard of like Nand Gates, let's make some Nand Gate tables. So that's just going to be not. Okay. So I need to use parentheses here and really talk about parentheses. Yet I mentioned, I believe, last class that if you're familiar with PEMDAS, parentheses, exponents, multiplication, addition, subtraction, division, addition, subtraction. That's the order of operations that Python uses as well. So the reason I'm doing this, the reason I need to do the parentheses here, let's just run this. So this is just going to invert this output. I get false, true, true, true instead of true, false, false, false. So let's do that. The reason that I need to put the parentheses is that if I don't, and let's look at a truth table where I don't, this will execute in a different logical order. So you can see we get false, true, false, false, right? So this is something completely different. And the reason for that is what's happening is that this not is pertaining to this first operand to the and. So it's only going to invert that first Boolean that it sees, right? So not true is false. So this turns into false, and true is false. Not false is true, and true is true. Not true is false, and false is false. Not false is true, and false is false, right? So this doesn't quite do what you think it would do. So that's what happens if I leave the parentheses off. It's like putting parentheses around the not in the first operand for the and. So that's important to know. I think there's right, there's a logical order of operations too, which is not happens before and happens before or, I believe. So that will be evaluated before that. So it's important to know. We could do something with, we could make, I mean, while we're here, let's just make NOR gates, because I know there's somebody out there who's like, finish it, make it complete. So let's look at our NOR gate truth tables. So that's false, 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 true. Is that, wait, is that like something else? Oh no, it's like, that seems familiar. It's just the opposite of or, which, because it's NOR. All right, anyways. So there's your truth tables. And just to recap what I'm doing, even though this isn't like numeric math, parentheses control order of operations like everywhere. It's a consistent mechanic in Python that if you put something in parentheses, that will be evaluated first. Just like in a math expression, even if you're not using, formal, regular integers and floats, regular numbers, there's still sort of a innermost parentheses to outermost set of parentheses pattern that is always followed everywhere in Python. So if there's some group of your code that you want to be a complete expression on its own, and you're not sure, maybe it's, the order of operations is going to handle that for you or not, just throw a set of parentheses around it just to be safe. Yeah, for the sake of producing working code, using a few too many sets of parentheses, erring on parenthesizing is generally better. Don't be afraid of parentheses, basically. Okay, so we got a breakout here. Just 2 minutes. What's the result of the following Boolean expression? And I'm just going to pop that into Slack real quick. Oops. Real quick here, before you start on that, if you notice the way I pasted that in, I pasted it in a code cell. So to make a code cell or a formatted cell in Slack, you can use triple backticks. So the backtick key on most keyboards, every keyboard that I've seen, is the backtick key is below the escape key, to the left of the 1 key, above the tab key. That should be where your backtick is. This looks like a single tick quote or an apostrophe character. It's not. It's a different character. So 3 of those in a row, and you'll get a little cell where you can paste in your answer. So when you paste in your answer, paste it in a formatted code cell. Cool. I'll just put 2 minutes on the clock. Remember those code cells. There we go. You can go back and edit messages too. Not that I really care that much. Cool. Nicely done. There you go. You got a single tick quotes there. That's good. That's definitely fine. Okay, cool. Sorry to make I'll stop it there. Sorry to make a stink. I hope I'm not making too big a stink about the code cell thing. The reason I want everybody to know how to do that is when you ask for help on Slack, if I just paste in a bunch of code just raw into Slack, it's going to be unformatted. Slack will take out spaces and things. Python being a white space formatted language. If you send me unformatted code and ask me to help you with it, I'm probably just not going to be able to help you with it. If I can help you with it, I'm probably just going to say, can you please format that and resend it in a formatted way, because it takes, in addition to like reading through your code and finding out what's wrong with it, I usually have to infer how you formatted it. And if formatting is the problem, then I can't tell without you putting it in a formatted code cell. So it's important for when you ask for help via Slack and when you're sharing code that that will be in a formatted code cell. Okay, cool. So real quick, a totally acceptable way of answering these questions is to copy paste this into your replit and go print, and that's true, and then triple backticks, paste that in, oops, true, and off the races. So I don't mind any of these questions that make it seem like you're supposed to like think it out. Just paste it into replit and print it off. That's what I do. Works for me. And then once you see the answer, then you can think through it or you can think through it and then run it and verify if that's what you're getting. But everybody did get the correct answer here. Cool. Bitwise operators. We're not going to get too much into these. They do exist if you know what they are. Here they are. We've got the tilde character, which is our bitwise not. Ampersand is our bitwise and pipe or vertical bar is our bitwise or. Yeah, like I said, we're not going to worry about these. If you're coming from another language, you know what bitwise operations are. You want to play around with them. There you go. But yeah, we're not gonna, like I said, we're not gonna dive into that. Exclusive or is the caret or hat symbol. This is, and that's why if you're familiar with like logic tables, so I didn't discuss XOR. XOR is essentially the same as not equal. Not equal is like saying not equal is true if A is different from B, right? If A is different from B, that's essentially an exclusive. This is logically identical to an exclusive or. So you can use not equal, or you can use caret for exclusive OR operations. I gotta say, they don't really come up that much, at least in our material. They're not that common. Okay, order of logical operations. We have our bitwise operators, not and or, and then we have our logical operators, not and or. Like I said, if the bitwise ones don't make sense, don't worry about it. Oh, or isn't represented here. That's just exclusive or. That's kind of funny. Bitwise operator tilde not is like that. That's a whole can of worms that I don't want to get into in class. If you want to look, if you're curious about bitwise operators, you can look them up. But since you'll see them, we just mentioned that they're there, but we're not. You don't need to know how to use them for now. Sorry to be. Usually, I'm happy to dive into concepts, but yeah, sure thing. But I just want to make sure we get through today's material. So sorry. I want to, but I'm restraining myself. Okay. What do each of these return? And I'm just going to let's see, can I get away with pasting these? No, I can't. Nope. That's good enough. I'm just going to do 2 minutes for this one. All right, cool. Go ahead and paste in your answers. I'll just pop in the answer there. All right, we're about halfway through. When we come back, we're going to start in on a new topic. We're going to start in on control flow. So we'll be introducing one of the major topics in the overview that we've been going over. So it's good timing. We'll use the last half of class for control flow. So let's have a 5-minute break. Let's reconvene at 8 after the hour. do this. Okay, cool, let's reconvening. Let me find my text editor here. I'll get my screen share going and we'll start. Oh, here it is. Okay, cool. So control flow. So this is a cool looking diagram that I don't really find helpful to understanding code, but it's there. You can reference it. It's in the GitHub repo if you want to look at it. But basically what this is saying is, our code, our program from the top to the bottom encounters a condition. A condition is any expression in Python that can be true or false, that evaluates to true or false, or can be understood as true or false. So it's anything that expresses a Boolean, basically. So if the condition is true, we have special code to run for the condition. If it's not, then we just skip that code. So let's write some control flow. So just to be clear, where does this fit in our overview? This is the start of control flow. So we have if, elif, and else. Okay, so we'll start with if. So like I said, just any expression that's true or false. So we looked at, these are expressions that give us true or false. And where are they? Those comparison operators. I didn't write them down this time because we kind of covered those before. So the comparison operators equal, not equal, greater than, less than, greater than, equal, less than, equal. These are our comparison operators. Right, so these combined with these are how we're going to construct a lot of different conditions. So not all conditions will use those, but you'll see it's any expression it's going to give us a true or false value, and there's a number of ways to do this. So we could do that something like A equals hello, and B equals goodbye. We could say if A is equal to B, we'll say print A and B are equal. Oops, I forgot to make that into a string. There we go. Of course, they're not equal, so that's not going to run, right? So we could check if they're not equal. We could say A and B are not equal, right? Oops. And this print here, this is just some arbitrary. This is just meant to represent some arbitrary code, right? Yeah. And this is just working with strings, so might be able to do some more interesting things if we work with numbers. So let's do 30 and 59, just because why not? So if A and B are not equal, let's do smaller numbers, 3 and 5. Print, let's do print A to the power of B. Cool. 243. So print, I'm just going to print this off fin for finished, right? That way we know when our program is ended. We know that this line has been run. We know that the program is ended. So whether or not this is true or false, it's going to run the code after the condition is done. And oh gosh, I forgot to mention this. I'm indenting this underneath here. And that's necessary. Remember, I've mentioned that Python is a white space formatted language. So the way that it knows what code is to be executed if this is true is by what is indented underneath this if, right? So the syntax here is I use the if keyword, then I have some condition that's going to give me a true or false value, and then a colon to let the Python interpreter know, okay, I'm done with the condition part, and now I'm gonna write the body of the if. So the body of the if, it knows that this is the body of the if by the fact that this is indented underneath the if. The indentation follows fairly loose rules. It is literally any number of spaces. I could use a single space. Please don't do that. That makes incredibly hard to read code, but it would work. I could use 2 spaces. There are people who do like 2 spaces. I don't personally like it. But 4 spaces is standard. So for me, I have my editor set up, and if you're in Replit, you can change these settings, and I recommend that you do, because I'll need you to change them if you meet with me or somebody else. I'm going to be using 4 space indentation. So this is, since it's a formatting thing, I've talked about like, well, you can use your own stylistic preferences. Don't make a stylistic choice about indentation size. Even though Replit starts you off with a 2 space indent by default, go in and change that in the settings. There's a little gear icon on the left in Replit if you're in Replit. If you click on that, about halfway down, there's an option that says indent size, and you can change that from 2 to 4. There's also another one that says indent type, and make sure that's on spaces, and that'll put in spaces instead of tabs, which is also important. So don't make a stylistic choice around spacing. Just use a 4 space indent. If you're on a 2 space indent in your editor, change it to a 4 space indent. If you like the 2 space indent, just eat it. Just do a 4 space indent. This is less up to a stylistic choice than other things, because it's syntactically important in Python, right? It's part of Python's syntax. If I try to combine 2 space indented code with 4 space indented code, that's liable to cause issues. So indentation has to be consistent. Okay, so how does it know when the code is no longer in the body of this if? It knows that by when the indentation ends, right? So this is no longer in the body of the if. So this is no longer in the body of the if. This code is going to run no matter what, whether this condition is true or false. So it's no longer in the body of the if. If we make this true, the conditional code runs, the body runs, and this also runs. Okay. Of course, I can have multiple conditions. So let's say if A equals B, we'll do A times B, or A to the power of B. We could also do if A is not equal to B. Let's do something else. Let's print B to the A. If A is greater than B, let's do something like this. Sorry, let me kind of change this. Oops. Let's say A is B. equal to not equal to, oops, and greater than, and we could do another one for less than. Okay. So A is not equal to B and A is less than B, right? So both of these things are true, right? It can be true that A is not equal to B. And if it's not equal, it's got to be greater than or less than. If they're both numbers, that is, if one of them or both of them are strings, then we can't really say whether a string is greater than a number or not. Not as easily. There are too many ways of answering that question, so there's not an obvious one. So yeah, so A is not equal to B and A is less than B, right? So we can have multiple ifs in our program, obviously. So I want to introduce this idea that we can, each of these are independent, right? Each of these ifs are independent from each other. So anytime you see an if that has nothing to do with another if, at least on its same level, right? So all of these ifs are going to be checked by the interpreter, right? So one thing, often you'll have code let me do it like this. I'll come back to that. Often you'll have code that, so this is the code that you want to run if the condition is true. You might have code you want to run if the condition is false. And you might say, oh, well, yeah, that's just this code, right? This is the code that you run if it's true or false. This code doesn't care whether this condition is true or false. This code is going to run either way. So this is not, we don't think about this as the false path, right? So if this is true, we have a path for the true, for the code to take, if for the interpreter to take if that condition is true, but we might want to put in an alternate path if the condition is false, right? So if A equals B is false, then the only thing left is that it's not equal B. Well, it could be greater than or less than, right? Well, I guess I'll show this in a second too, right? So if it's not equal, well, if A equals B is false, then A is not equal to B, right? So with this code, this is going to run if the condition is true. Else means run this code if the condition is false. So the code indented under the else, in the else block, will be the code to run if that condition is false. Yeah, so let's just run that, right? So A is not equal to B. Let's kind of try to rebuild the other part of our program here. Kind of did it for me. Okay, that's weird that it did that. Okay, whatever. So if they're not equal, then I can check if A is greater than B. And if it's not greater than B, then it means it's less. We know they're not equal. So So if it's not greater, then it must be less. So I can say else here. So I can put conditions inside of other conditions. And that's what I want to show here. Does else, so let's just see. Does else just pertain to the if it immediately follows? That's like 99% correct. And I'll show the I'll show the slight exception to that. Yes, so yes. The answer is yes. Okay, so I'm going to cover nesting, and then I'm going to kind of come back to that idea in a second. Okay, so here we have, our condition. If the condition is true, we have this code. Else, we know they're not equal, and we could check, well, maybe A is greater than B or it's less than B. So we'll check if A is greater than B, then print A is greater than B. If it's not greater than B, well, we know it's not equal to B because we already determined that up here. If it's not equal and it's not greater, then it's less than B. So we can determine that like this. So notice this if and else is indented under the else here. And the code for when its condition, A greater than B, is true, is indented under it, right? So we have this if indented under the else, and its true path indented under it, and then its complementary else, etc. Right? Now, there's a number of ways we could lay this out, right? We could check the inverse condition, perhaps, just as an alternative to this. We'd end up having to put the code up here, and then our else would be that they are equal. But this will work the same. So A is not equal to B, A is less than B. Then, okay, cool. So there's another keyword here. So sometimes when your condition is false, you don't just want to automatically run some other code. Sometimes you want to say, okay, well, if it's false, instead check this other condition. In that case, there's a keyword, there's a third keyword, elif. And I promise that's the last one, right? So elif takes another condition after it. I forgot to mention this explicitly, it's implied, but else takes no condition after it, right? There's no, oh, sorry about that. I'm still getting used to, I got a new computer just last week, and I'm still getting used to the keyboard. So sometimes I hit the page buttons, they're right next to the arrow keys. I've never had a keyboard like that, so I keep jumping around. Apologies. So else has no condition after it. So I don't need to say else A equals, oops, I kind of forgot to rectify that. Okay, so I don't have to say else A not equal B, right? This is not proper syntax. You can see it's syntax error, invalid syntax, and it points at this. It's like, no, I don't know what you're trying to do. This is, the complementary understanding though, right? Like if it's not equal, if it's false that it's equal, then it's true that it's not equal. So, we can just say else. So I can't check another condition with else. If I want to check another condition, and there's times that you do, you use elif. So that's our three conditional keywords: if, elif, else. Okay, so let's say I will just explicitly check this: if A not equal B. Now this code's going to run the same as when this was an else. It just happens, right? These conditions are complementary to each other. A equals B is the perfect complement to A not equal B. When one is true, 100% of the time, the other one is false. When one is false, 100% of the time, the other one is true, right? So they are perfect opposites. They're just the inverse of each other. So this is logically identical to just having an else. But for demonstration purposes, I'm just going to keep it this way. So this will work the same. Let's say I want to, it's kind of redundant to say they're not equal and A is less than B. If A is less than B, I kind of know they're not equal. So it's kind of irrelevant to have not equal. So maybe I could say, I could get rid of the not equal portion and say elif A is greater than B, print A is greater than B, else print A is less than B. So this was the sort of slight caveat to the question asked. The question was, does else pertain to the if it immediately follows, the if or the elif? So in this circumstance, we have if A is equal to B, print A is equal to B. If A is greater than B, elif A is greater than B, print A is greater than B, else print A is less than B. And we could follow this up with another elif. A is less than B. Again, these last two conditions are perfect complements of each other. Kind of, although they'll both be false when they're equal to each other, but we're checking for equality right up front, so kind of doesn't matter. Yeah, so this if, elif, else. So this is an example of, sort of a complete view of, simplistic but complete view of Python control flow. Now we can have as many elifs in here as we want. I'm struggling to think of an example, honestly. What would be a good example? It's not uncommon that you'll see examples or, sorry. Yeah, I'm giving a jumble of words. It's not uncommon that you'll see several elifs followed by an else. The else is not even necessary, and I showed that with, we could just end it with some number of elifs. So if you think about this, these are chained together. These are sort of bound together by in this system, right? So only one of these is going to run. As soon as it finds one that's true, it executes the code within that condition, and then it doesn't check any of the other conditions. It doesn't even check them. It doesn't even bother. The interpreter just skips to the end of that chain of conditions. So you can think about these. I think of these as like chained together, like a chain of conditions. Now let's look what happens if let's say I do have that elif A not equal to B. Print A is not equal to B. Okay, so remember before, our program would print A is not equal to B, and then it would also print if A was greater than or less than. So it would do both of those things. Let me see if I can find, yeah, right here. Right here. So this was the output that we would get. We would say, oh, it's not equal and it's less than or it's greater than, right? This is not going to have that behavior because as soon as it sees that they're not equal, it's never going to even bother checking the other conditions, never even a little bit. So in this case, in this particular case, you have to watch out for writing code like this. This code is dead. it's just what we call dead code. It's never going to be run because one of these two conditions is going to be true. So you have to watch out for that. So when you're checking conditions, chaining if after if is different than chaining if after elif after, or elifs after ifs, right? So that those are logically distinct things to do. So saying if is different, is logically distinct from saying if elif elif. The order in which you check things matters, right? So if I check A is not equal to B after checking A is equal to B, like one of these two things is going to be true since they are, perfect diametrically opposed non-Venn diagrams. I don't know. There's a perfect disparity between their results. There's no circumstance in which this code will ever be evaluated by the interpreter. So it's dead code. So you have to be mindful of that. So the order matters. What you're checking matters. So you really have to think through each of those. When you're learning to code, there's this thing that is often really useful to like develop like kind of rules of thumb, kind of like little tricks like, oh, whenever I see this scenario, I use an if and an else, or whenever I need to do math, I use numbers, or so. I don't know what you're like. So it's easy to want to develop like simple axioms of truth and like simple consistent ways of doing things. And what I see people do often is say, okay, I'm just only ever going to use ifs and check conditions explicitly. And I get the urge to keep things simple, but that's logically different. You're going to end up writing logically different code than using elif and else together, right? So another assumption that I see people make is, oh, I want to be thorough, so I'm always going to end, it seems like it would be a good practice to always end my ifs with an else. There are schools of thought around this. There are people who think that, and I'm not for or against that as a philosophy. I think it has its time and its place in certain paradigms of programming. If you're a beginner, I don't want you to worry about that particular thing. Just some problems will require a single if. Some problems will require multiple ifs, like just if, not if elif. Some will require if elif with some number of elifs. Some will require if else. Some will require if elif else, right? So the way that these can combine are fairly numerous and all distinct. So all this to say, be careful about making assumptions that might feel like they're going to make things easier, because it might lead you down the wrong path. And I've seen that happen. It happened with me when I was first learning to code. I'm like, I'm always going to use else. I'm never going to use elif because it's kind of extraneous. And I just wound up writing just really funny, silly, hard to deal with code that wasn't doing what I was wanting it to do, until I finally realized, oh, the simple answer is that I actually just need to learn all three of these tools and think through every problem, which is not a simple answer. So the simple answer is there is no simple answer. And that's the best I've been able to come up with, after a year and a half of working with students and being a learner myself and being a educator now. So be careful about making easy assumptions around this stuff. So that being said, you only have 3 keywords to learn how they work, right? If can stand on its own, and it can start a chain of conditions. Else always terminates a condition. It can come after an if or an elif. It always terminates a chain, and it can come after an if or an elif. Else absolutely does not have a condition after it, right? So there's not else A greater than B or something. It's just else, just by itself. If you try to put a condition after it, you'll get a syntax error, which is fine. Go get all the syntax errors you want. That's the right thing to do, really. If can stand on its own, else, or it can start a chain of conditions. Else has no explicitly given condition after it, or you can think about it as its own condition. Else's condition is, hey, if everything else was false, then do this. This is your last thing, right? Necessarily, it ends that chain of conditions, and it can come after an if or an elif. Elif cannot stand on its own. It has to come after an if or another elif. It doesn't come after an else because, like I said, an else stops that chain of conditions, right? So we can't have an elif out here. You can see it's not even going to highlight elif 6 is less than 10. It's not even going to highlight correctly because there's not an if in front of it. If A equals B. So that'll make that valid. So those are, I know the rules can seem a little mercurial at first, but yeah, that's the breakdown. It just takes some practice and you'll get used to it, I promise. Cool. Let's see if I missed anything in here. Okay, cool. All right, we got a little breakout here. Just trying to see, I'll just kind of look through and see if there's anything in there worth covering that I didn't talk about. I know this is a lot. This is, I consider this our first like big push for a concept in a lesson. So I'm not, I don't quite have a sense of like where everybody's at, we're still a new cohort, so I'm not sure about everybody's experience level. I'm kind of assuming that we have a good amount of beginners in here, and I know there's some people that are have been around before and do have some more coding experience. But yeah, like if you're looking at this and you're like, this is confusing, like don't worry about it. It takes a little time, takes a little bit of repetition. I promise this stuff, if I can do it, you can do it too. So let me get this sent over and you can start your breakout. And I'll put 5 minutes on the clock. So again, just to reiterate, I would prefer, you can answer these however you want, but I would encourage you to, go into your replit or whatever environment and just run the heck out of your code, like run it a lot. And if you get errors are not bad things. If anybody ever told you that errors are bad things and that programmers shouldn't get errors, they don't have any right to say that. You should get all the errors. So yeah, run your code, test it out, play around with it in your replit or your environment. Okay, cool. I'm just playing around in here. All right, I'll go through a solution for this. And I'm going to introduce a little bit about workflow. We haven't introduced the, also using this other function, the input function. Input function is kind of half print, half input. So it prints out whatever thing that you pass to it, to the console when you run the code. And then it waits for you to input something into the terminal, and then it returns that. So input does return whatever you input into it in the terminal, and then returns that as a string. So that's why I'm casting it to an integer, which, by the way, you can cast a string of digits to an integer. Cool. So this says, write code snippet that checks two numbers, X and Y. Oh, and I'm not seeing any, shoot, is this not updated? Oh, sorry. Yeah, it looks like we've got quite a number of results in here. Oh, we've got some people writing functions too. Great. Okay. That's awesome. So, sorry, let me. Yeah, so the input function returns a string, and then I'm just casting it to an int because I'm just going to put in valid numbers. Then we're going to sum those. So this question says, write a snippet that checks two numbers, X and Y. Check if the sum of the two numbers is greater than both numbers. If it is, print both the numbers are positive. So if the sum is greater than X and the sum is greater than Y. If it is print, oh, I just read that, sorry. Check if the sum is equal to either number. If it is, print at least one number is 0. Otherwise, the synonym for otherwise, by the way, is else. Otherwise, print at least one number is negative. So we'll say if XY sum is greater than X and XY sum is greater than Y, print, that'll be, oops, both numbers are positive. If the sum is equal to either number, so I'll say elif, I'll just, actually, I'll just do both of these. We'll just say elif XY sum is equal to X, or XY sum is equal to Y, print at least one number is 0. And then this will just be an else. Else, at least one number is negative. Cool. So now the input functions they're cool. Don't get too stuck on using them. Don't throw them all over the place. They can make testing your code kind of clunky, but they are fun and they are worth knowing. So let's see here. So input a value for X, let's say 5, and a value for Y, we'll do 9. Both numbers are positive. Okay, let's run it again. We'll say 8. and 0. At least one number is 0. Let's run it again. This time we'll do 0 and 8. At least one number is 0. Good. We'll restart, and then let's try a negative number. -3 and 9. At least one number is negative. Restart. Let's do 9 and -5. At least one number is negative. Restart. Now this is going to be interesting. I'll try a negative number, -7 and 0, and which one will take precedence? At least one number is 0, so we didn't get one number is negative. Let's try it again. We'll try it in the opposite order, 0 and -4. At least one number is 0. Cool. So it's always good to just kind of explore around and try to think of like what different combinations you can do to test something out. Since I see some people, and I know some of you all have been through previous prior premium preps as well, prior premium preps. Since I see some people doing functions, I'll give a quick function solution. Def code snippet. We'll just do this. I'll take in X and Y as arguments. We will talk about functions later, but the cool thing here is this makes testing it pretty easy because I can just do both positive, one negative, the other negative, 1 0, the other 0, -0, 0, negative. Let's do this. So we'll just say both positive, one negative, the other negative, one is 0, the other is 0. Oops. We'll do negative here, 0 here, and I'll do negative here, 0 here. I forgot both negatives though. Negative, negative, and I actually forgot both zeros as well. All right, so that'll give me a, oops. This will give me a variety of test scenarios to look at. And I'm not going to go through the logic of each of these scenarios. But yeah, that would be an example. I like doing things this way because I can just figure out what my tests should be ahead of time. And these are little tests, right? They're going to test different inputs, and for each of those inputs, I have an output that I could expect. And I could notate that for each of these function calls here. But we'll get it more into writing our own functions as we go too. It'll be for another lesson. Cool. All right, and that puts us at homework. We're right about, we've got just a few minutes left, so I think we can just call it early. Let's see. We have a question here. Instead of and, can we use amp or the caret? No, those are the bitwise operators. They will have unexpected behavior if you try to use those. I would say, like I said, we mention those because there's something that you're going to see, just so you know that these do play a role and they are valid Python in certain circumstances. We don't go in depth into them. But yeah, if you want to learn more about those, you'll have to look them up. But they are, to be clear, they are not interchangeable with and, A and D, or OR, things like that. So that's a good question though. Yeah, you're welcome. Cool. We'll wrap up there. If anybody's got any questions, feel free to post it. Let me stop the recording and we'll go from there.